I welcome once again on platform of YourPedia Education, and this video is related to the ongoing Airport Authority of India ATC series and the videos related to physics. My present topic today, this topic is very important topic for your Airport Authority of India exam, and that is photoelectric effect. It is a modern physics, and this is actually very important topic. So, photoelectric effect is the topic in this. What we are going to discuss is what is the photoelectric effect and duality of light, particle nature, wave nature of light. I will be showing you some diagrams, some photographs, so that mental map is made. I will give you some equation, photoelectric effect equations, some diagrams, some graphs we will discuss, how the current, photoelectric current changes with intensity, changes with the frequency, what do we mean by stopping potential and cutoff or threshold frequency, and then we will do some numericals. I think this is sufficient for your exam. So, this is one of the very important topics for this particular exam. I think I will pull this particular topic in half an hour, and so just learn this, make notes. You will also get these PPTs if you want and questions. So, just revise it. So, let me start this topic. Photoelectric effect was very important experiment, and this experiment proved the particle nature of light. Light has dual nature. Light behaves as wave and light behaves as particle. This is called duality. So, light has dual nature, wave like nature, particle nature. Now, there are certain experiments, there are certain phenomena in which wave nature of light can be visible. You can see that, you can feel that. There are certain phenomena in which particle nature of light can be observed. Now, we have already done Young's double slit experiment. In Young's double slit experiment, we have seen wave nature of light. We have done interference and constructive destructive interference, diffraction. This is wave nature of light. So, interference, diffraction, polarization, these show the wave nature of light, because one wave interfering on another wave and resultant amplitude is calculated. That is, the wave only can do that. You already have done the progressive wave, y is equal to a sine of omega t plus theta, another progressive wave, y is equal to a dash sine of omega t plus theta dash. So, when you superimpose, you get resultant wave nature. There are certain phenomena in which particle nature of light can be seen, photoelectric effect. There are certain phenomena where both wave and particle nature is seen, reflection. I will show you how that is to be observed. So, let us start our lecture. This is a very important diagram. Photon is energy packet of radiation. Light is there, the light is coming to me in the form of radiation, that is energy. Einstein said that when radiation is coming to you, that radiation has photons inside it, and each photon has energy packet. So, that energy packet of the photon can be calculated in the form of Planck's constant, speed of light and frequency of that particular light or wavelength of that light. So, hc by lambda or h nu is the energy of one photon. So, photon of light comes. Why this is made curved? Because it shows it is a wave, maybe. So, radiation comes, photon hits the surface, and every surface has electron, nucleus ke around electrons are there. So, that electron will be ejected, and electron is a charged particle. So, electron will be ejected out. You can see the particle is ejected. So, radiation comes and particle is ejected. This was the experiment, that the light has particle nature also, because particle, photon as energy, particle inside that. So, this photoelectric effect was the evidence that light is a particle, and for exam you need to know that this gives you one proof that light is a particle. And another things, light since travels through vacuum, empty space, that also says that yes, for wave to travel you need to have space. So light is made up of some particles, that is photons, and light is in the form of light has displaced the particle nature. So this entire experiment photoelectric effect was related to that. Now wave particle duality of radiation is very important. Wave nature of light can be visible in certain patterns, as I told you, like interference pattern. Particle nature of light can be visible in certain patterns like photoelectric effect. So somebody asks you, what is interference pattern? Sir, it shows wave nature of light. What is photoelectric effect? Particle nature of light. Now see this. If I give you radiation in the form of light source or something, and if that radiation hits some surface and ejects some electron from that, आपने स्टैटिक करंट एक्सपीरियंस किया होगा. स्टैटिक करंट, इफ यू टच अ सरफेस आपको करंट लगता है, करंट होता नहीं है, करंट की फीलिंग आती है. स्टैटिक करंट, उससे कोई डैमेज नहीं होता. इट इज नॉट इलेक्ट्रिक करंट, स्टैटिक करंट. वेन एवर इन द सन, आपकी कार सन में, आपकी धूप में, लाइट में आपकी कार खड़ी है, योर कार इज पार्क्ड इन द सन. द मोमेंट यू ओपन द डोर आपको करंट लगता है, स्टैटिक करंट. यू नो व्हाई इट इज देयर? Sun radiation hits the metallic surface, and when the radiation of sun will hit the metallic surface, electron will be ejected from the metallic surface. Now the moment you as a human body, you will touch that metallic surface, here it is a positive charge, electrons are not there, they are ejected. So some electrons will flow from your body to this metallic surface, and you will get a feeling of current, because in your mind the feeling of current is there. So that signal goes to the brain and you feel like having a shock. Actually it is not a shock, but that feeling comes कि आपको shock लगा. Static current is an example of this. Now you have also seen the prism and dispersion. The other day we were discussing about the rainbow. Rainbow when total internal reflection and dispersion is there. So the light goes on the prism, and then as per the wavelength it gets dispersed. So that is the wave nature of light. So this dispersion, wave nature of light, this is photoelectric effect, is a particle nature of light. That is how we should know it. I was giving you example of mirror reflection. Mirror में reflection होता है, you know, mirror has a reflection phenomena. So the moment light comes, suppose I have, this is a mirror in front of me, suppose I throw a ball on this, ball is a particle, I throw a ball on it, it will also be reflected, right or not? Suppose I throw a light through torch on the mirror, this will also be reflected. So that means the reflection shows particle nature of the light also, reflection is showing the wave nature of the light also. So if the wave hits on the mirror, it is also getting reflected. If a particle hits the mirror, it is also getting reflected. So reflection has again both the examples. Now this one is a very important chart. This is very important chart. Mark it important for your exam. In the exam he will give you certain phenomena. Mark it important. He will say that interference, diffraction and polarization show which of the nature? You will say, sir, wave nature. So wave nature is shown, this is wave, and that means yes, wave nature is shown. Interference, diffraction, polarization is showing the wave nature of the light. Okay. Photoelectric effect is showing what? Particle nature of light. Particle nature of light and not wave nature. Photoelectric, particle nature, no wave nature. Interference, diffraction, polarization, wave nature, no particle nature. And reflection and refraction show wave nature also, particle nature also. Wave nature also, particle nature also. So remember this very important topic, very important thing, very important slide for you. Another example I want to give. Einstein said when the light comes, it comes in the form of photons. Can you see some photons of the light coming here? And Einstein said that each photon has energy packet. So this photon, this photon, this photon, this radiation is coming, and this radiation has many photons inside it, and every photon has energy of h nu, which nu is the frequency, lambda is the wavelength of that photon, and c is the speed of light, h is a Planck's constant. So this equation was given by Einstein. So radiation comes, it comes in the form of packets, energy, and that energy packet hit the surface. Now this energy packet hit the electron and eject electron outside. This is photoelectric effect, right? So for light to eject electron, light should also behave as a particle, because collision takes place between two particles. One particle collides with another particle. That means light has a particle nature. That is photoelectric effect. Double slit experiment, Young's double slit experiment we have already done. There is a slit 1, there is a slit 2. From slit 1, the wavelets move forward. Slit 2, wavelet move forward. It is like this. In a water tank, throw two stones. Where the stones are thrown, waves will start propagating, and these waves will basically superimpose. So there is a wave like this, and there is a wave like this. When these two superimpose, maybe you get these waves like this, constructive interference. So this particular double slit experiment was example of interference wave nature, because this is a wave nature. Particle nature, wave nature, very simple. So photoelectric effect is a particle nature. Another way. So I will be showing you couple of slides here to make the concept clear. So what is photoelectric effect? It is a phenomena in which electrons are emitted from a metal because electron absorb energy from the light. Light has energy in the form of its photons. Energy of the photon is h nu. So that energy is taken by electron, and electron take that energy and they are happy. Remember one thing, not every electron take the equal energy. Listen carefully. Suppose I will tell you that energy can be calculated in kilojoule, it can be in electron volt. Electron has 1.6 into 10 raised to minus 19 coulomb charge. Voltage is calculated in volt. And in electrostatic we have studied that charge into voltage is energy. So charge into voltage is energy. So 1 electron volt is how many joules? 1.6 into 10 raised to minus 19 joule. So that means energy can be written in the form of electron volt also. In 1 joule, how many electron? So just equate it to 1 joule, and then you can find out how many electrons are there. So 1 electron volt is this much joule. 1 joule में कितने electron होंगे वो आप निकाल सकते हो. Anyhow, so electron, this photon has some particular energy. Now electron 1, electron 2, electron 3 which are ejected. The electrons which are ejected, not every electron has same energy. Some electrons are moving with maximum kinetic energy. Some are not at all moving, their kinetic energy is 0. It is possible. So depends where the electron is. आपने orbit किए हुए हैं, आपने वो Bohr model किया हुआ है. You know that electrons are in outermost shell, electrons are inner shell also. You have done that. So not every electron which is ejected has same energy. There are electrons which just sufficient energy to come out of the metal. Kinetic energy is 0. Some are, they come out of the metal and move with maximum energy. We will be discussing those cases also. Minimum energy required for electron to come out is basically explained through a term called work function. We will discuss that particular thing. So what is the minimum energy required for electron to come out? If the electron, minimum energy required for electron to come out is 1 electron volt, let us say that is a work function, and this chap is giving you 5 electron volt, photon gives you 5 electron volt, minimum energy required for electron to come out is 1 electron volt. Suppose 1 electron gets 5 electron volt, not every electron gets 5 electron volt, some are sitting down, they don't get 5 electron volt. So 5 electron volt, 1 electron volt to come out, the rest 4 electron volt is its energy. But suppose there is an electron which is deep inside the, it's a shell, so it will only get 1 electron volt. So it will merely come on the surface, that's it, out of the metal, that's it. But think of some electron which is getting less than 1 electron volt, it will not be in position to come out of it. That is a story. So that story is very important for you to know. What happens is, photon has particular energy, 5 electron volt. Is every photon has same energy? Yes. If frequency and wavelength is same, every photon has same energy. Is every electron ejected has same energy or not? No. That is the crux of photoelectric equation from where question comes. Is every photon has same energy? as far as the frequency of the radiation is same, as far as the wavelength of the radiation is same, which is same, the energy of the every photon is same. Is every electron has same energy? No. Some electron move with the maximum kinetic energy, some electron do not move at all, they just come out of the metal and stand there, relax there, kinetic energy is zero. Some electron cannot even come out of the metal. Why? Because they have not even got that much of energy. So ये तीन केस आपके पास बनते हैं. फोटोन की सबकी एनर्जी बराबर, इलेक्ट्रॉन सबकी एनर्जी बराबर नहीं. Not every electron comes out. Some electron come out with and move with maximum energy, kinetic energy. So that is all we have to see. Anyhow, now there is something which is called light intensity. Understand, light intensity means how many photons are there in the light. Understand that. So intensity means number of photons. That is very, very important for you to know. And I want you to write this thing in your copy. Intensity of light means what? Intensity of light means how many photons? How many photons in light? कितने particles हैं light के अंदर? So 1, 2, 3, 4, that is intensity of light. How many photons? And the current means how many electrons? Current means how many electrons are ejected. Photoelectric current. Current is nothing but flow of charge. Charge is electron. So current means how many electrons, intensity of light means how many photon. And now if I ask you, is there any relation between current and intensity? You will say yes sir, more the intensity, more is the current, right or not? More is the intensity, more is the current. So if I draw intensity current graph, you will get like this. More is the intensity, more is the current. More are the photons hitting, more are the electron ejected. So one photon will eject one electron. This is the typical example which you should see, right? So more photons are coming, more electrons are ejected, and then one experiment is done that the moment these electrons are now coming from the metal, let's create a positive side here. Let's create a positive side of the battery here so that the electrons will start moving towards this. We also create a negative side so that we don't want electron to come out. That is called stopping potential. I will discuss that concept later on. Stopping potential क्या है? As of now, अगर मेरे को current create करना है, let the photons come, let the electrons come, let these move in a circuit and I get a current. Suppose I want to find out how much potential I should apply so that electron does not flow. That is called stopping potential. So what do we mean by stopping potential? What do we mean by stopping potential? Stopping potential is important term. What do we mean by stopping potential? If this is a positive side, electron will be attracted towards this. Electron is a negative charge. But suppose I put it here negative charge, cathode. So what happens is this electron is stopped from coming because negative will repel. The potential of the battery, this side is negative, you see now, this is a negative, that means I am trying to make a stopping potential experiment. Now suppose I apply a negative potential such that not even a single electron hits here, not even a single electron comes here. Which electron will tend to come here? Most energetic electron. Is every electron moving with the same energy? No. Some electrons are very calm, they will sit there only. They don't have energy. Some electrons are have maximum kinetic energy. They will try to rush this side. Stopping potential will stop those electrons. So that means E into V dot is half of mv square. Maximum. That is kinetic energy maximum. That means maximum kinetic energy electron, the electron with maximum kinetic energy is equal to the charge of electron into stopping potential. From here we calculate what is the stopping potential. So stopping potential is that potential applied across this so that even the most energetic electron does not reach this electrode. And if the most energetic does not reach, तो कम energetic भी नहीं आ पाएगा. So current does not flow. So how much negative potential I should apply so that no current flows is called stopping potential. निकालते कैसे हैं? Maximum kinetic energy of electron divided by charge on electron gives me stopping potential. any of that is a separate experiment. This diagram I want to show you. Intensity of light, photoelectric current. More the number of photons, intensity of light मतलब more number of photons. क्या होता है intensity of light? More number of photons. More number of photons. More the number of photons, more the electrons. Current is more number of electrons. So it's very simple. More the number of photons, they will eject more electron, intensity of light. Now, as I keep on increasing the potential, you see, intensity means more the number of electrons. This current, sorry, the photo current is nothing but more the number of electrons. Now, one very important thing you should observe from the previous experiment. Now, that is what I want to show you. As I keep on increasing positive potential, now this is the positive potential, this is the negative potential. Positive potential, negative potential, this is the stopping potential, which I just now discussed. Stopping potential, the potential at which the current flow will be 0. This side is current flow will be 0. So if I make the potential negative, at particular value no current will flow. Stopping potential. If I keep on increasing the potential, what happens? More and more electrons start moving towards the electrode and current starts flowing. Now, more the number of electrons ejected, more is the current flow. So this is intensity. This side is, this I shows intensity. Intensity is related to number of photons. More the number of photons, more will be electrons ejected. More electron ejected, if I give positive potential, more electron will reach the electrode and the current will keep on increasing. After particular limit of positive voltage, even if you increase the voltage, number of electron will not increase now. Saturation aa jayega, number of electrons will not increase and hence current will remain same. Does current depend upon intensity? Sir, yes, depends. Because intensity, number of photon. More the photon, more is the current. So you can see for high intensity, more current. Low intensity, less current. Now how the current changes with voltage? Sir, if you increase the voltage, more electron will reach the electrode. See this. If you increase the positive potential this side, more electron will come here. लेकिन उतने ही इलेक्ट्रॉन आ पाएंगे जितने यहां क्रिएट होंगे. The number of electron reaching here cannot be more than number of electrons ejected. Number of electrons reaching here cannot be more than number of electrons ejected at this point. And number of electrons ejected depends on number of photons, that is intensity. Intensity is number of photons. More are the number of photons, more are the electrons ejected. More are the electron ejected, more electron can reach here if I give positive voltage that attracts these electrons, and I keep on increasing voltage. Let us say there were 10 electrons, because 10 photons were there, 10 photons released 10 electrons, let us say. Now all these 10 electrons reach this side at particular value of positive potential. Now suppose I increase potential further, do you think more electron will come? No. All 10 has already reached here, and that is the reason now if you increase the voltage beyond a limit, number of electrons coming or reaching will not increase. So current becomes static. Very good diagram, very good diagram. Intensity current diagram. With more intensity, more current will be there. How the current changes with voltage? At particular voltage, current becomes 0. No electron will reach that particular electrode, stopping potential, and intensity, how it changes. Is this clear? Let's go forward now. Another diagram. Another very important diagram. As I told you, photoelectric effect, couple of diagrams there are in photoelectric effect. Now, another thing I want to tell you is energy of photon. Energy of photon is h nu. Nu is the frequency, h c by lambda. Mu 1 is more than mu 2. So energy of the electron, energy of the photon 1 is more than 2. Higher the frequency of radiation, more is the energy of the photon. More is the energy of photon, more will be kinetic energy of the ejected electron. Listen carefully. Higher is the frequency of photon, one photon will eject only one electron, but if the energy of photon is more, it will not only eject electron, it will eject electron with high kinetic energy. So kinetic energy of electron will also be high, and stopping such electron, you need to apply more stopping potential. Higher the frequency of the photon, higher will be kinetic energy of the ejected electron, and if you want to stop it, you need to apply more stopping potential. So stopping potential for high frequency photon, stopping potential for particular electron ejected by high frequency photon will be more, though it will be negative. And at this point does not matter if the current is related to number of electrons. Whether electron is with high kinetic energy or less kinetic energy, current does not depend upon kinetic energy of electron. Listen this carefully. Current depends on number of electron, which further depends upon number of photons, called intensity of light. Very, very important statement to be written in your copy. Current depends upon number of electron, charged particles, which further depends upon number of photon, because one photon is ejecting one electron, and number of photons further depends upon intensity. That means current depends upon intensity, and we saw this intensity current. Second statement I am giving you. Second statement is kinetic energy of ejected electron depends on frequency of photon. Number of photon nahi, frequency of photon. So kinetic energy of electron depends upon the frequency of ejecting photon, and higher the kinetic energy, more needs more stopping potential. It requires more stopping potential. तो अभी तुम देखो, अगर फ्रीक्वेंसी बड़ी है तो काइनेटिक एनर्जी भी इलेक्ट्रॉन का ज्यादा रहेगा, काइनेटिक एनर्जी ज्यादा रहेगा तो उसको रोकने के लिए स्टॉपिंग पोटेंशियल आल्सो रिक्वायर्ड इज हाई. So that means current does not depend upon, current comes into picture once electron is ejected. Electron will be ejected once potential is positive. Current in the circuit only will come if potential is positive. If potential is negative, current will not be even coming there. So current will come if the potential, even if potential is negative, some electrons will hit. So current will be positive. Current negative तो हो ही नहीं सकता. It's not, current cannot be negative because either electron is flowing or it is not flowing. Current will be, if you potential is negative, some energetic electron still will reach the electrode. So current will be there. Like you see, current here is there, current here is there, even if potential is negative. The moment potential is increased, the current depends only upon the intensity or number of electron, not energy of the electron. So one photon with high frequency or low frequency will give you one electron only. If frequency of the photon changes, mu1, mu2, mu3, it does not change the current. Number of photons change the current. Frequency of the photon does not change the current. So if you increase the potential after a limit, the current does not change. Very important diagrams. Now this is another very important diagram which says stopping potential into E is the work function. I will discuss with you what is the meaning of that. So what is the minimum energy required for electron to flow is called work function. Minimum energy required for electron to be ejected, to come out of the metal, is called work function. That is equal to charge into stopping potential. Charge into stopping potential. So you can calculate like that. So this, if you plot a graph with frequency of incident radiation, that is the frequency of photon, and stopping potential, so from there you can calculate. Stopping potential is calculated as work function of the metal, divided by charge on electron. So we need to do some of the, now we come to Einstein theory. This is basic theory behind photoelectric effect. Einstein said that electromagnetic radiation is having quantized energy, photon of energy. Each photon is of energy E is equal to h into nu. Nu is the frequency, or f is the frequency, h is Planck's constant. You need to know the values of Planck's constant and all. And the photon travels with the speed of light. So frequency can also be calculated as speed of light over wavelength. So if you give me wavelength of radiation or frequency of radiation, I can calculate the energy carried by this. It's a very interesting chart actually. You see what Einstein is saying. Einstein says that energy is coming with photon, as you can see this, and the electron is sitting in the metal. Now where in the metal that is sitting, nobody knows. This is the electron, this is the photon coming. This photon wants to take this electron out, but the electron is sitting W naught below. W naught below. What is W naught? W naught is the minimum energy needed by electron to escape the metal. It is called work function of the metal. For particular metal, some electrons are sitting at the top, less energy of photon is required to come out. Some electrons are sitting deep inside the metal, so more energy is required for that electron to come out. That means depending upon metal to metal, depending upon the material, work function हर material का अलग है. तो हर material के लिए energy required electron को बाहर आने के लिए अलग है. That means now photon में उतनी energy होनी चाहिए. Photon must have that energy to take out that electron. What is the minimum energy required for electron to come out? Work function. What is energy in photon? H nu. Photon will eject electron from the surface. Let us say photon has more energy. This photon has 2 electron volt and energy required is 1 electron volt. Now suppose you give 2 electron volt to this guy. Guy means this electron. If you give 2 electron volt to this guy, 1 electron volt it will come out. Now it has 1 electron volt more, so it will have kinetic energy. So what equation we got? Very interesting equation. Energy given by photon HF to this guy electron, some energy is required to overcome this barrier work function, plus another is spent by electron as kinetic energy. Now let us say there were so many people, so many electrons sitting here. Not every electron is having same kinetic energy. Some electron will be having maximum kinetic energy. So HF is work function plus kinetic energy of the electron. And if let us say my interest is only to take out this electron from the metal, not to give his energy, लेकिन उसको बाहर निकालना है बस, मेरे को जेल से बाहर निकालना है, फिर तू जा मर्जी जा. The minimum energy required to take it out is work function. Let us say kinetic energy is not there, so the frequency which is sufficient enough to take out the electron is called threshold frequency. Threshold frequency or threshold wavelength. So that concept is very important. What is the minimum frequency of the photon required? Let us say 1 electron volt. Now what is the frequency corresponding to 1 electron volt can be calculated. So minimum frequency required for this to take out the electron is called threshold frequency. This is a very interesting chart. Energy of photon, work function plus maximum kinetic energy. We have done this. Stop this particular thing and understand. Another very important chart. Suppose for particular electron, energy required to come out is 2 electron volt. 2 electron volt is required for electron to come out. But photon has 1.77 electron volt only. So no electron will come out. Suppose another photon has 2.25. Okay, it will come out and the rest of the energy, kinetic energy will be this. So this guy, green guy, is having kinetic energy, velocity is this. Third photon is coming even with high energy, 3.1 electron volt. So this guy will be having maximum energy. So as the energy in photon is increasing, the energy of kinetic energy of the electron is also increasing. How to calculate threshold frequency? Corresponding to 2 electron volt. If I say 2 electron volt corresponding to this hc by lambda, so what will be the frequency of this for 2 electron volt, that is called threshold frequency, to just eject the electron, that is called threshold frequency. And how to calculate stopping potential? यहीं दो ही जगह से क्वेश्चन आता है, threshold frequency, stopping potential. So 2 electron volt is the energy given by this energy given by photon is h into nu is equal to 2 electron volt plus stopping potential E into V naught. मैक्सिमम काइनेटिक एनर्जी कितनी है? लेट्स से काइनेटिक एनर्जी, मैक्सिमम काइनेटिक एनर्जी कितनी है? मैक्सिमम काइनेटिक एनर्जी ऑफ इलेक्ट्रॉन इज द एनर्जी इन द फोटोन माइनस वर्क फंक्शन. This is the energy in the photon minus work function gives you maximum kinetic energy of electron. So now if most energetic electron also is to be stopped, so the potential corresponding to that is stopping potential. So how do you calculate stopping potential? Energy of the photon minus work function over E gives me stopping potential. That is how it is calculated. So if you see the previous formula, previous equation, as I told you, energy of photon plus work function plus kinetic energy maximum. Now kinetic energy maximum is E into V stopping potential. So how do you calculate stopping potential? Stopping potential is maximum kinetic energy over E. Now if I make stopping potential 0, let's say this is not required. So energy of the photon is equal to work function. Energy of the photon is equal to work function. And this particular frequency or this particular wavelength gives me cutoff voltage. So question cutoff voltage kabhi aayega? Threshold frequency. So this is threshold frequency is work function over Planck's constant. Remember this, numerical aata hai. How do you calculate threshold frequency? Minimum frequency required for photon to eject electron is called threshold frequency. And if the frequency is more than that, so ejected electron will have kinetic energy also. So wavelength corresponding to work function. Now this wavelength is equal to work function over Hc is called cutoff wavelength. Cutoff. This one. Cutoff. So this दो जगह से cutoff voltage दो जगह से numerical आता है. Either he will ask you to calculate cutoff voltage, he will ask you to calculate threshold frequency, he will ask you to calculate the stopping potential. So remember this equation and remember the question you have to do. Same thing, maximum kinetic energy is photon energy minus work function. So how do you calculate the stopping potential? Maximum kinetic energy is E into stopping potential. ऐसे निकाल लेंगे. You have done this. Stopping potential कैसे निकालना है? Maximum kinetic energy over E. You can calculate that. ये diagram को make sense of it. We have already done this. Same ही चीज है. I don't think there is anything new. कट ऑफ वोल्टेज कैसे निकालते हैं? सर कट ऑफ वोल्टेज निकालने के लिए गिव मी वर्क फंक्शन and divide that with Hc. In some of the numericals, he will give you the value of H into C. Because C is constant, H is constant, Hc is also calculated. E is equal to Hc by lambda. तो Hc का यूनिट क्या होगा? E into lambda. E का यूनिट क्या होता है? E का यूनिट होता है इलेक्ट्रॉन वोल्ट और lambda का क्या होता है? मीटर. So Hc value is calculated in electron volt nanometer. Remember this. H Planck's constant, C speed of light. H into C has a value 12,000 something. I will give you the value. H into C has a value. What is the unit of Hc? Sir, energy is equal to Hc by lambda. Lambda is meter, but meter में नहीं होता lambda, nanometer में होता है. So E is calculated in electron volt and lambda is calculated in nanometer. So electron volt nanometer, that is Hc. That value sometime you need to remember. Work function is electron volt, that is energy. So how to calculate cutoff frequency? So work function divided by this particular value. Cutoff frequency you can calculate like this. Now numericals. Read this. Work function is 1 electron volt. Light of 3000 angstrom 10 raised to minus 10 is incident on metal surface. Velocity of the electron will be what? Yes, tell me what is the answer for this. Stop the video, calculate it. I give the solution now. Energy of photon, work function plus kinetic energy. Now energy of the electron is, as I told you, energy of the electron is h into nu, hc by lambda. hc का वैल्यू वो ये यूज कर रहा है, hc is using this value and lambda is 3000 angstrom. So hc is 12375 electron volt into nanometer. If it is nanometer, this is 10 to the minus 10, so I can make it 10 to the minus 9, 300, and then you can take this 1237 electron volt nanometer, something like that is to be done. So unit you have to put it properly. This hc, this one is hc, hc in electron volt angstrom, electron volt angstrom. So W naught is given in electron volt, so E maximum can be calculated. And electron volt, how to convert that into joule? You have to multiply electron volt with charge on electron to convert it into joule. Practice करो खुद से calculate करने का, then only you will be in position to get it. Next question. When photon of energy h nu are incident on surface of photosensitive material of work function h nu naught. What is nu naught? Threshold frequency. Minimum frequency required. Threshold frequency. H nu. So energy of photon, work function plus kinetic energy maximum. That means h nu is equal to h nu naught plus kinetic energy maximum. Kinetic energy of all electron is not same. Kinetic energy of the fastest electron is this. Kinetic energy maximum is h nu minus nu naught. So answer is C. Kinetic energy of not every electron is this. Kinetic energy of maximum electron is this. We have done this. Read this. hc का वैल्यू उसने दे दिए तुम्हें, याद कर लो इसको. hc, value of hc is 1240 electron volt nanometer. Electron volt nanometer. What is nanometer? 10 to the minus 9. ये है hc. Now he has given you light frequency nanometer. Wavelength of light is 400 nanometer. Kinetic energy of ejected photoelectron is also given. So what is the work function? h c by lambda is equal to work function plus kinetic energy maximum. Now he has already given you hc as 1240 and wavelength in nanometer is given 400, so that becomes the energy of photon. Work function is given as work function we have to calculate. Kinetic energy is 1.68 electron volt. So what is the work function in electron volt can be calculated. ये याद कर लो 1240 इलेक्ट्रॉन वोल्ट, 1240 इलेक्ट्रॉन वोल्ट को याद कर लो. Threshold wavelength. What is threshold wavelength? The wavelength hc by lambda required just to overcome the work function. Maximum energy of emitted photoelectron threshold. So work function, it gives you work function. hc by lambda naught is this. And there is a light of frequency this. So hc by lambda is equal to hc by lambda naught plus kinetic energy of electron. And he is asking you maximum kinetic energy of electron, sorry. So hc का value 1240, lambda का value up 1240. If we have to put it this angstrom, can you tell me how much is 1800 angstrom in nanometer? Can I say 180 nanometer? 1800 angstrom 10 to the minus 10, nanometer 10 to the minus 9. So hc is given 1240 divided by 180, that is energy, and divided by 230 is work function. So I think you can calculate. This is simple question. H is 6.6 into 10 to the minus 34. Speed of light is 3 into 10 to the 8 meter. and if you divide it with E, you get electron volt. So this is how you calculate value of Hc. (1240 electron volt nanometer) Hc. Photosensitive metallic surface has work function this: if photon of energy this falls on the surface, electron come out with maximum velocity this. When the photon energy is increased to this, maximum velocity of followed electron will be. Yes, stop the video and try to find the answer. Answer is this. Work function remains same because the material is same. Frequency nu1, frequency nu2, energy V2, energy V1, right. So this is the difference. Only thing you changed is the energy of photon, 2h nu, 5h nu. Velocity square, you can compare it. All electrons ejected from surface by incident light of 200 nanometer can be stopped before travelling 1 meter in the direction of uniform electric field. Now see carefully. What is the stopping voltage? Electric field is given, sir, 4 Newton per coulomb. Distance is given, sir, 1 meter. So if electric field and distance is given, stopping potential can be calculated. Electric field into distance. So how much distance electron travels? Potential difference is E into D. So that gives me stopping potential. Work function कैसे निकलता है? Stopping potential मेरे पास है. So how do you calculate the work function of the surface? So energy h nu is equal to work function plus kinetic energy maximum, and that kinetic energy maximum is E into stopping potential. So all electrons ejected from surface by incident light 200 nanometer. So h nu, h into this frequency is hc by lambda. Hc by lambda. Lambda is given as 200 nanometer. Stopping potential is this much. So E value I know. From there I can calculate threshold frequency. (1240) divided by 200, that gives me the value of energy. So energy of electron is hc by lambda. What is hc? 1240 electron volt nanometer divided by 200. This much electron volt is the energy of the photon. What is stopping potential? Stopping potential or maximum kinetic energy is equal to, you know, E into V naught. What is E? E, you know, E into V naught. So E, let it be like this. V naught is 4. So 4 electron volt. 4 electron volt. How much is this coming? 6.2 electron volt. So 6.2 electron volt, 4 electron volt plus kinetic energy maximum, that comes 2.2 electron volt. Okay, so I believe you have understood this all. We come to an end of this very important topic. You are watching the series of 50 most important topic of physics for your ATC exam. Do not miss 50 most important topics. Do not miss 25 my favorite 30 questions series of the physics, because that will be more than sufficient for you to get all 30 marks in physics. Enjoy it. Physics is a simple subject, very simple subjects. Do not miss the live classes, and physics is a very simple subject. ATC is a great opportunity. Just give your 2 months and you can, I am very sure you can hit it big. Keep watching. Thanks a lot for this particular video, watching this video. Thank you.